Physics numericals. Magnetic field intensity at the center of a coil of 50 turns, radius 0.5 meter and carrying a current of 2 amperes is B equals mu 0 Ni by 2R. So substituting the values, we will get 1.25 multiplied by 10 raised to minus 4 Tesla. A long straight wire carries an electric current of 2 ampere. The magnetic induction at a perpendicular distance of 5 meter from the wire is. So here B would be equal to 10 raised to minus 7 multiplied by 2I divided by R, which will be equal to 10 raised to minus 7 multiplied by 2, I is 2 and R is 5. So that will give me 8 into 10 raised to minus 8 Tesla. That is option B. Next question, the ratio of the magnetic field at the center of a current carrying coil of the radius A and at a distance A from the center of the coil and perpendicular to the axis of the coil is. That is, magnetic field at the center versus magnetic field at a distance of A from the coil will be equal to 1 plus x square by A square the whole raised to 3 by 2. So your x is equals to A, that is the point at which we are supposed to find, which will be 1 plus a square by a square the whole raised to 3 by 2. So we will get this as 2 root 2 on solving. That is option D. An electron having a charge of 1.6 multiplied by 10 raised to minus 19 coulomb and a mass of 9 multiplied by 10 raised to minus 31 kg is moving with 4 into 10 raised to 6 meters per second speed in a magnetic field 2 multiplied by 10 raised to minus 1 Tesla in a circular orbit. The force acting on electron and the radius of the circular orbit will be. Force will be equal to EVB. E is known, V is known and B is known. Substituting all of them will give you 1.28 multiplied by 10 raised to minus 13 Newton. Radius will be mv square by r is equal to EVB, which will give you r as mv by EB. Substituting all the values here also, so you will get value of r as 1.1 raised to 10 raised to minus 4 meter. So the correct answer here is option D. Force being 1.28 multiplied by 10 raised to minus 13 and radius being 1.1 into 10 raised to minus 4. Next question, a proton moving with a velocity 2.5 multiplied by 10 raised to 7 meters per second enters a magnetic field of intensity 2.5 Tesla, making an angle 30 degree with the magnetic field. The force on the proton is F is equals to QVB sine theta. Charge is known since it's electron, since it's a proton. Velocity is known and B is known. At the same time, angle is given. Substituting all the values would give you an answer of 5 multiplied by 10 raised to minus 12 Newton. That is option B. Next question. An alpha particle and a proton travel with same velocity in a magnetic field perpendicular to the direction of their velocities. Find the ratio of the radii of their circular path. So ratio of their radii is basically R is mv by qb. So ratio of the radii, that is R of alpha to R of the proton, would be m mass of alpha divided by mass of the proton multiplied by charge of alpha, charge of the proton divided by charge of alpha. That is, radius is directly proportional to the mass and inversely proportional to the charge, as B and V is same. Both are traveling with the same velocity and under the influence of the same magnetic field. So your R alpha by Rp, that is radius of alpha to the radius of the proton, would be mass is in the ratio 4 by 1 and charge in the ratio 1 by 2. So it will be 2:1. That is option C. When a charged particle moving with a velocity v is subjected to a magnetic field of induction B, the force on it is non-zero. This implies that when the force on it is non-zero, angle between V and B can have any value other than 0 and 180, because when basically the formula is F is equal to QVB sine theta. So non-zero means this sine theta value cannot be equal to 0. Sine theta is 0 when theta is 0 and 180. Therefore, the angle between them, that is V and B, cannot have a value of 0 and 180. That is option A would be the correct answer. Angles between V and B can have any other value except for 0 and 180. Next question. Two thin long parallel wires separated by a distance B are carrying a current I ampere each. The magnitude of the force per unit length exerted by one wire on the other is. Force per unit length will be equal to mu 0 by 4 pi 2 I1 I2 divided by R. So since both are carrying the same current, this will be mu 0 by 4 pi 2 I square by B. So your correct answer here is option B. A conducting circular loop of radius R carries a constant current I. It is placed in a uniform magnetic field B such that B is perpendicular to the plane of the loop. The magnetic force acting on the loop is. Net force on a current carrying closed loop is always 0. When it is placed in a uniform magnetic field. So the correct answer here is option C, 0. The unit of electric current ampere is the current when flowing through each of the two parallel wires spaced 1 meter apart in vacuum and of infinite length will give rise to a force between them equal to. So here force per unit length on two parallel current carrying conductor is given by similar formula to what we had here. F is equals to, that is F by L is equal to 10 raised to minus 7 multiplied by 2 I1 I2 divided by A. Here we have 10 raised to minus 7 multiplied by 2. Current is 1 that is unit current, and your A is that the distance between the wires is also 1. So your correct answer will be 2 multiplied by 10 raised to minus 7. That is option B. Next question. A hydrogen atom is in an excited state corresponding to an energy level of minus 0.85 electron volt. The frequency of the photon emitted if it comes down to the ground state of minus 13.6 eV in a single jump is. Energy of the photon h nu will be equal to En minus Ep minus 0.85 plus 13.6, which will be 12.75 eV. So your frequency would be 12.75 multiplied, your volt will be 2.75, converting it to joules, 1.6 into 10 raised to minus 19 divided by h, which is 6.63 multiplied by 10 raised to minus 34. Solving this will give you approximately 3 into 10 raised to 15 hertz. So your correct answer here would be option A. What is the de Broglie wavelength of a 2 kg mass moving with a velocity of 10 meters per second? A straightforward de Broglie formula with all the values are given. So correct answer here would be 3.3 multiplied by 10 raised to minus 35 meters. Next question. An electron having Ke of 50 electron volt, its de Broglie wavelength is lambda equals h by root of 2 MeV, where Ev will be your kinetic energy. Substitute the values, you will get your answer for wavelength to be 1.732 angstrom. That is option A. Next question. A 200 gram cricket ball is thrown with a speed of 3 multiplied by 10 raised to 3 centimeter per second. What will be its de Broglie wavelength? H lambda equals to h by mv. Substitute h value 6.63 multiplied by 10 raised to minus 27 erg second, that is in CGS unit. 200 gram is the mass, speed is 3 into 10 raised to 3. So this will give you an answer of 1.1 multiplied by 10 raised to minus 32 centimeters. That is option A. Next question. The energy required to excite hydrogen atom from n equals 1 to n equals 2 is 10.2 eV. What wavelength emitted by the atom when it returns to the ground state? So 1 by lambda equals r 1 by p square minus 1 by n square, which is equal to r 1 by 4 minus 1 by 9, which is 5r by 36. So your lambda is 36 by 5r. Substitute the value of r, you will get the value of lambda. So option A would be the correct answer. Of the following transactions in hydrogen atom, the one which gives an absorption line of lowest frequency is A. Option A is n equals to 1 to n equals to 2. Option B is n equals 3 to n equals 8. Option C is n equals 2 to n equals 1. And option D is n equals 8 to n equals 3. Now E is equals to h nu. E should be minimum, then frequency is minimum. Energy would be minimum when it is moving from n equals 1 to n equals 2. So option A would be your correct answer. Next question. A light bulb is placed between two plane mirrors inclined at an angle of 60 degree. The number of images formed are, number of images formed would be 360 by theta minus 1, which would be 360 by 60 minus 1, which would be 5 in this case. So option C is your right answer. A beam of monochromatic blue light of wavelength 4200 Armstrong in air travels in water of refractive index 4 by 3. Its wavelength in water will be mu of water with respect to air is speed of light in air divided by speed of light in water, which is wavelength in air divided by wavelength in water. So wavelength in water would be equal to 4200 divided by 4 by 3, which is 3150 angstrom. That is option D would be your right answer. The refractive index of water and glass with respect to air is 1.3 and 1.5 respectively. Then the refractive index of glass with respect to water is here. Refractive index of glass with respect to water. So refractive index of water is given as 1.3. Refractive index of glass is given as 1.5. Refractive index of glass with respect to water would be option D, 1.5 by 1.3. Next question. The frequency of light ray is 6 multiplied by 10 to 14 Hertz. Its frequency when it propagates in a medium of refractive index 1.5 will be, original frequency is 6 multiplied by 10 to 14 Hertz. When light moves from one medium to another, the frequency does not change, hence the frequency remains same. Hence correct answer will be option C, which is 6 multiplied by 10 to 14 Hertz. Next question. An object has image thrice of its original size when kept at 8 cm and 16 cm from its convex lens. Focal length of the lens is, magnification is 3 times, so m is plus or minus 3. So I can use m is equal to f divided by f plus u. Now for virtual images, m value will be 3 plus 3. So I will have 3 equals to f divided by f minus 8. For real image, it will be minus 3, it will be f divided by f minus 60. So solving both the equation, will get the value of f as 12 centimeter. That is, the correct answer here is option C, between 8 centimeter and 16 centimeter. Next question. The radius of convex lens, the radius of the convex surface of a plano-convex lens is 20 centimeter and the refractive index of the material of the lens is 1.5. The focal length of the lens is 1 by f is equals to mu minus 1 multiplied by 1 by 20 minus 1 by infinity. So from here we will obtain the value of f as 40 centimeter. That is option D. Angle of minimum deviation for a prism of refractive index 1.5 is equal to the angle of prism. The angle of prism is, so we need to find what is the angle of prism. Now by prism formula, we have refractive index equals sine A plus delta by 2, that is angle of deviation, divided by sine A by 2, which will become 2 sine A plus A by 2 divided by sine A by 2, which can be written as 2 sine A by 2 cos A by 2 divided by sine A by 2. Sine A by 2, sine A by 2 will cancel out, we'll get 2 cos A by 2. So your n would be equal to 2 cos A by 2. So cos A by 2 would be equal to n by 2, which will be cos A by 2 will be equal to 0.75, which is approximately as given. Angle is 41 degrees. So correct answer is option B, 41 degrees of 4. So angle A by 2 is 41 degrees. So angle A will be 82 degrees. So correct option will be option C, 82 degrees. Next question, if two waves represented by y1 equals 4 sine omega t and y2 equals 3 sine omega t plus pi by 3 interfere at a point, the amplitude of the resulting wave will be about. Now, Imax by Imin equals A1 plus A2 the whole square divided by A1 minus A2 the whole square. This should give out to be 4 by, which is given to be 4 by 1. So A1 by A2 will be 3 by 1. So correct answer here in this case will be, so here it says amplitude 1 is 4, amplitude 2 is 3. So your resultant, and the phi value is pi by 3. So the resultant amplitude would be given by A1 square plus A2 square plus 2A1 A2 cos phi. So which will come out to be 6 approximately. So correct answer will be option B. In Jan's experiment, the ratio of maximum to minimum intensities of the fringe system is 4:1. So Imax by Imin is 4:1. So Imax by Imin is A1 plus A2 the whole square divided by A1 minus A2 the whole square, which will be 4 by 1. So A1 by A2 can be obtained from this as 3:1. That is option B. Next question, a star moves away from Earth at a speed of 0.8 c while emitting light of frequency 6 multiplied by 10 raised to 14 Hz. What frequency will be observed on the Earth? Now, observed frequency V dash will be equal to V, that is, you can say N dash will be equal to N 1 minus V by C. Substituting your values over here will give you 1.6 multiplied by 10 raised to 14, 1 minus 0.8 C divided by C. So solving this will give you 1.2 multiplied by 10 raised to 14 Hz. So your observed frequency will be 1.2. That is option B. Next question, the angle of incident at which reflected light is totally polarized for reflection from air to glass is mu is equals to tan of the polarizing angle, tan phi. So tan phi is tan inverse refractive index, that is option D. Last question, in Young's double slit experiment, the intensity on the screen at a point where the path difference is lambda is k. What would be the intensity at a point where the path difference is lambda by 4? So we know phase difference is equal to 2 pi by lambda multiplied by path difference. So for path difference lambda, phase difference is 2 pi for path difference of lambda. And for path difference of lambda by 4, phase difference would be pi by 2. Now I is equal to 4 I0 cos square phi by 2. So I1 by I2 will be equal to cos square phi 1 by 2 divided by cos square phi 2 by 2. Phi 1 is 2 pi, phi 2 is pi by 2. Substituting those values, we'll get k by I2 will be equal to 1 divided by half, which will be equal to 2. So k I2 would be equal to k by 2. So correct answer is option B, k by 2.